Hello, my name is Kyle Chun, and over the summer of 2022, I'm conducting a research project for an internship. This research project is looking at various types of touchscreen technology in mobile devices. The hope is that by helping us better understand this technology, we can develop experiments that can help drive student interest in science, technology, engineering, and math. Throughout this series of videos, I'm going to be documenting my progress, my thoughts, my ideas, and my experiments as I go. I have various types of mobile devices I'm going to be testing with so we can gather different types of data. So join me as we play around with some phones. Now, there is a little bit of background information that you need to know before we get into this topic. Touchscreen technology, also known as projected capacitive touch detection technology, or PROCAP, is essentially, the way it works is it generates an electric field. This electric field is generated by something called ITO, a series of materials that is scattered in a grid-like pattern across the screen of the phone. This grid-like pattern of material generates field, or generates an electric field because it is a semiconductor. Glass by itself can't generate electricity. When your finger touches the phone, this electric field generated by the material is disturbed. The microcontrollers that are monitoring on the X and Y axis will then detect this disturbance of the electric field. By coordinating which or where the location of this disturbance is, the phone will know exactly where you touch the screen, and as a result, it will then react. For our first experiment, we're going to be looking at the various types of paper. We're going to be placing each piece of paper on top of each phone. We're then going to be placing our control, which is our stylus, which has a set diameter and has a flat and or robust kind of surface, so that unlike a finger, which is malleable and can bend, we'll have a constant amount of surface area being applied for touch detection on each mobile device. So for the various types of paper that we're going to be testing, we're going to be using magazine paper, we're going to be using newspaper paper, and we're going to be using notebook paper. So let's get started. Begin testing the phones. The first phone we're going to begin with is an iPhone 5S. It's an older iPhone, and so I'm curious as to see whether placing a normal sheet of notebook paper, then my finger will pick up touch. Let's find out. And so here I'm going to press the lock screen numbers to see if it'll pick up touch. As you can see, even though we placed a notebook paper on top of the phone, it still is picking up touch. The next phone we're going to be going on to is an Android Z833. It's a ZTE model. As we can see, the Android phone is still picking up touch, and I'm not touching the screen. Even though notebook paper is on top of the screen, it still can detect touch. Alright, the next phone we're going to be using is another ZTE phone. Now, as for the exact model of this phone, I'm kind of unsure, as this phone is very, very old. As we can see, it can pick up touch even though a notebook paper is on top of the screen. I do wonder though, if I place it completely on top of the phone, will anything happen? Let's see. Yeah, even if I place it completely on top, it still picks up touch. The next phone we're going to test is a newer model. It is an iPhone SE Generation 2. We're first going to begin with a piece of notebook paper, just like all the other phones, and then we're going to test to see whether it can pick up my finger. As we can see, it can still detect my hand despite the notebook paper being on top of the phone screen. Alright, so at the end of our tests, we saw that none of the phones had an issue detecting human touch through a piece of paper. I went on to go ahead and test different types of paper, from newspaper to magazine paper, and still there was no issue with detecting touch. The next test that I'm going to do is with different size end bits of a ratchet. These have varying amounts of surface area at their tips, so they might serve as a good way to see what the resolution or how big something needs to be if the phones even detect that touch at all. So let's go ahead and do that. The really wide one right here, then a second, kind of widest one, then a smaller one, and then finally we have just this point right here on the end of this bit. And I'll post the measurements for like the circumference and things like that, and kind of like the captions to this video, which I'll add. So we're going to start off moving from this way and we're going to test each phone with each bit. So we're going to start off with a very small fine point. And this is to try to figure out the touch sensitivity or resolution of each of the phones. So we're going to first start off with the ZTE, which I don't know the exact model of. So let's go ahead. It looks like the very small fine tip, the phone isn't picking it up. Let's continue to see if it'll pick it up anywhere. So it looks like the very small fine tip, the ZTE, cannot pick it up. Let's try the ZTE Z833. It looks like the, it did look like we had a bit of a touch response right there for a brief second. If I really push down, it does seem to kind of pick it up. But, yeah, it does really seem to pick it up. Alright, so we're going to then move on to this one, which is an iPhone 5S. It's an older kind of phone. And so we're going to go ahead and see whether it will pick up this first bit size that we're trying, which is the smallest one. Doesn't appear to be picking anything up. It looks like the iPhone, unlike the Android, this one that briefly picked it up, can't seem to detect the very small point. So let's try on the last iPhone, which is an iPhone SE Generation 2. And it looks like the iPhone SE Generation 2 can't seem to pick it up. We're now going to get to our second smallest base or surface area of contact, which is this smaller, not smaller, but slightly larger end bit drill. They're not end bit drill, but end bit for the ratchet. So we're going to go ahead and attach that, as you can see, and then we're going to start again. First starting with that ZTE. I don't know the exact model of it. And it seems that the ZTE can't seem to pick up the bit. Oh, if we really hold it down on the 8, no, maybe that's just a one-time thing. Let's see. Because it picked it up on the 8, which is very interesting. If I really push down, yeah, it seems maybe the 8. Try the 0 and the 0. So the 8 and the 0 appear to be, oh, it looks like if I really push down on the phone, it seems to be able to detect the touch. Now, it could be that maybe some areas are less sensitive than others, but the left-hand side and around the 8 and the 9 are pretty sensitive. So let's try with the ZTE 833, or sorry, Z833, which is the second one here, and we're using that same second smallest surface area size. Oh, it looks like this one picks it up. And this one appears to have more sensitivity, or appears to be able to detect it a bit more. And this screen does have a history of a bit glitching, so I wouldn't say that even though I pressed the 3 and it detected the 2, I don't think that's because of this. This phone has a history of this side kind of glitching out, so I don't think that that is part of the fact that this is this. We're then going to move on to the iPhone 5S. And it appears that the iPhone does not seem to pick it up. And now let's move to the iPhone SE Generation 2, which is the newest phone that we're testing here today. Now, it's not new as of 2022, but it came out around 2020. And you can see that this iPhone SE Generation 2 doesn't seem to have the capability to pick it up. Even though we're pressing, let's see if I press, I don't want to break it, but yeah, doesn't seem that it can pick it up. Now let's move on to the third smallest, or not third smallest, but the second largest, second from the largest base size, which is this one right here. And it's gonna, go ahead and thrash it, and then we're gonna repeat the process. Moving up to the ZTE, once again the one that I don't know the exact model of. The 8 was sensitive last time, and we have the 8 is able to pick it up. Now, I would think that the larger it gets, the higher the probability of detection becomes. Now, for some reason, the edges of the phone, at least on this specific model, seem to be less sensitive than the middle, which I think is very odd. Let's move to the ZTE Z833. We have almost no issue picking it up. Look at that. And it makes sense that, this one, it's getting easier for this phone to detect this one because the surface area is getting larger, and as surface area gets larger, it does make sense based off of what we know for the phone to have less of an issue picking it up. So now we're going to move to the iPhone 5S. And we see there is no detection. And I am curious to know whether that is due to the material. It looks like even the iPhone SE Generation 2 can't seem to pick it up. So I have a theory, and that could be that these two Androids versus iPhones must use some kind of different detection method. The last size that we're going to try is the biggest n-bit size of the 4 that we're going to test. And, based off of what we've seen so far, we should see progressively easier detection. So this one should have no issue detecting this one. And we can see that even the edges now seem to be able to detect the biggest base size that we're using. See? Alright. So we can see that the ZTE, of which I don't know the model number of, has no issue picking it up. Let's now move to the ZTE Z833. Yeah, you can see that phone is glitching out. That happens normally, so I would consider that as detection of the edges. Yeah, you can see this one, also the ZTE Z833 has no issue detecting it. Let's now move to the iPhone 5S. And you can see that there is no detection still on the Apple side of anything, even though this is the largest base size we're using. Let's now move on to the Generation 2 iPhone SE. And we can see there is no detection still. So what this must mean is that the detection method between the Androids and the iPhone for touch must be different. And it must, for iPhone, it could be a different method entirely. So what we found was that, with the smaller point, most of the phones weren't able to pick it up. With the second smallest, the Androids had almost, a little bit, or they had an issue picking it up, but they're able to detect it. And we saw no detection on the Apple side for any four of these end bits for the ratchet. And then as we got larger, the base contact, the surface area, we saw an easier progression, or an easier amount of detection, or larger amount of detection as we moved with a large up in terms of contacts, base size, surface area, especially on the Android side. And the Apple phones, the 5S that we're testing and the SE Generation 2, we're not able to detect any of them. So, what this could mean is a different detection method in terms of between Android and iPhone. It could be a combination of several things. It could be the material that the bits are made from. And so really, yeah. So that concludes the second test, or actually the third test now that we did today on these phones.